Jens has given me the opportunity to talk about a couple of ideas that I've been doing some research on in the last year or two or three, around certain parts of or aspects of making content accessible that I find especially interesting. And while the matter at hand is really complex and maybe intellectually challenging once you really drill down into it, just talking about it a little bit shouldn't be too challenging, so I hope you still have enough energy to follow what I'm going to share here. Presentation is labeled How to Make Mathematical Formulae, Bar Charts, Network Diagrams, or city maps really accessible. And just as a warm-up, I'd like you to look at the next couple of slides and kind of make up your mind what is in these slides, what the content on these slides does have in common in terms of such content. I'm thinking about formulae, and I've been taught that mathematicians say formulae and not formulas, but you can have a long discussion about that already. I vaguely remember this kind of stuff from school. I haven't done much in mathematics since then, and an expectation that I would be able to provide an alternate description of this formula would really put me into trouble. It's another variation of the theme. I've just grabbed some stuff from some documents I've been looking at recently. So we have formula, we have bar charts, looking like this, or like this one here. It's a variation of the theme. We could as well have pie charts, communicating similar information in a slightly different way. You could have graphs like this one, which is a three-dimensional plot of some data. Or you could have something like this, where you have a map of the world with visual indicators saying something about the relationship between number of births and number of deaths, obviously varying from region to region. You have another variation of map-based quantitative data regarding the migration of monarch butterflies in Northern America over spring and summer and the seasons and so on. You have maps used in some other ways. This is the expenditure of the public sector in Germany, split by federal state, or a similar one reflecting how much people earn in each of the states per hour. You have also stuff like this. So at first glance it's a table. It's actually the same table I was showing, I think, yesterday with all the empty data cells. And because the way this table is to use quantitative indicators per cell. So in each of the cells of a matrix, the color is conveying some information, some intensity. In the end, a table-based heat map. Or you have something I don't know exactly how to call this, like org charts, or it's not, maybe you could argue it's a flow diagram, or flow chart. Or like here, it's a classical flow chart, establishing relationships between different content entities and implying certain directions going from one to the other. You have a flow chart with some picture-based information. You have a map used as a map as opposed to being part of the graph. You can find out useful things. So this is the area where I live in Berlin. You can find out about parks and shops and things like that. So this was one from one of the previous conferences. This is using Google Maps to find out how to get from my hotel to the conference venue. Or something completely different, music scores. And not that I ever could play this, but and again, it can become quite complex. You have several musical instruments playing at the same time, or voices singing at the same time. All kinds kinds of stuff. So looking at these examples, and I've of course selected certain types of figures and avoided others. I think it's fair to say that none of these are your typical painting, photo, or similar such image. Some of them contain text, also in a relevant fashion. So for many of these diagrams, if you omitted the text, it could become useless. Not necessarily completely useless, but it would suffer. At the same time, just reading the text from, let's say, one of the bar charts in order, whatever, left to right, top to bottom, or whatever, that alone would not make a lot of sense. Or reading a mathematical formula, just like all the characters in the formula, one after the other, without offering some additional information, would probably not get you much. At the same time, if you think of publications or documents you deal with, if you have a bar chart or a flow chart or a mathematical formula, would you rather say it's highly important content, or is it content that you could as well skip because the majority of the content is also reflected in the text or other parts of the content? And I would argue that in many cases, and for different reasons in some cases, it is very important content. So focusing on graphs, which would leave something like music scores on the side, a main purpose of graphs is to make sometimes highly complex data more readily accessible to most users. And I'll show an example in just a second to illustrate this case. The problem is, if you can't see the bar chart, let's say, it's not only that you can't see the bar chart, you can't take advantage of the extra value provided by the fact that you're looking at the bar chart as opposed to, let's say, the raw data. So I would argue you're disabled twice. And while you could work around some of the limitations by providing a decent alternate description, it becomes pretty counterproductive once you look at less than trivial bar charts or other less than trivial graphs. Because if you put every important piece of information about a bar chart with 25 data entries in a piece of text, it gets relatively long and becomes more challenging to read the full text than just looking at the bar chart and immediately seeing what's going on in the bar chart. Just to look at one of the graphs again. So this is average salary per hour in federal states and Germany, indicated by color indicators, ranging from yellow being very little to dark blue being quite big. And you can just look at it and find out certain things relatively quickly. And you see where it's dark or where it's yellowish. And as soon as you understand that dark blue is good and yellowish is relatively poor in comparison, you can quickly make up your mind, and you see certain centers on the screen, like there's three federal states that are very similar next to each other, part of the former GDR, and then north and east is also an area with lower centers and so on. So it's virtually within 1 to 3 seconds, you get a lot out of this graph. If you look at the same information in raw form, it becomes immediately obvious, at least to me, it takes much longer. And there's more data in it than is reflected in the graph. But it takes much longer to find out anything from this table. Yeah? So what are the rich federal states, or where is it especially bad, or how does it vary between men and women and so on. So the data is there, but you would probably spend a few minutes making up your mind of what the interesting aspects are in this table. So graphs are very often used to point out certain things to the reader. So as opposed to having the table, and opposed to having a piece of text saying, well, yeah, Bavaria is especially rich and Mecklenburg-Vorpommern is especially poor. And even based on text, takes a little while to build your mental model and understand, okay, Northeast is poor and the South is rich and stuff like that. You would still not immediately see how different it is. So the author of the chart, whether intentionally doing it or kind of just happening to be doing it because he thinks it's a cool graph to display the data, would steer you towards certain conclusions, not invented conclusions because they are founded on data, but he will kind of steer you towards looking at the height of the salary in different federal states and give you access to this intended meaning that in a very easy fashion, as long as you can see and don't have any other disabilities that make that process slower or impossible. But he doesn't block you from drilling down into the data in some way. So while in this chart, it's not reflected whether male or female employees earn more money or not, it still gives you some numbers. So it gives you the average in North Rhine-Westphalia as being 19.63, and you can make your own conclusions. This is very different, or slightly different, so on. So while steering the reader towards a specific interpretation of the graph, it doesn't block you from deriving your own position. So you argue, or begin to argue, that the split is unfortunate. You should not be splitting between under 15 and then 15 through 18 and 18 through 20. You could say, well, I would split between 16 and 19, and you could try to come up with your own conclusions, so you're not constrained to the proposed interpretation of the graph. And that's very important. These are very important perception and reasoning processes when people look at graphs. And so first access to a graph is very easy. Most of us would just look at it and get it, unless it's a horrible graph, it also happens. And if you have further questions, you can use that same graph to find out more or make up your mind whether you agree with the author or not. And this is much harder looking at raw data, and also still pretty hard, even if you have a decently written copy explaining what the author believes is the case. Just to give you a good impression. So for those of you who can't see, it's a table with many numbers, and it's just confusing at first glance. So what could we learn from these considerations? There are a couple of problems to improve this. So just to make this clear, I believe alternate descriptions for this kind of figures just doesn't help. So having an alternate description for this graph is at best a band-aid. You can of course write something down like saying people in Baden-Württemberg earn the most, and then there's Bayern, and so forth. But it's not giving the same quality of information. Also, in addition to the graph, providing the raw data table in a fully accessible fashion, by nicely tagging the table with all the table header cells and what have you, is not helpful. It's already a showstopper for a sighted person just using the computer in ordinary fashion. It's even more so for anybody having to use some aids, and whether it's screen reader or magnification-based navigation for low vision people and so forth. So neither a tag table nor an alternate description is useful on the same level as the graph itself. So you could say, well, if you look at these graphs, there is structured information. It's not that it's a painting and you could argue what the objects on the image are. There are clearly defined entities of data. We have the axis of the bar chart, numbers, clear identification of what the components are, whether it's a salary or the birth rate or whatever you have. So it's very clear-cut information. It's very well structured. So why is there no mechanism in the world of HTML or PDF or anywhere else that provides decent access to such a graph? And I would argue there is no established understanding of how graphs work. So not even talking about accessibility yet, just talking about graphs per se. So how does a graph work? And the way you can find out that a lot of people don't understand how graphs work is you can look at programs that create graphs from tabular data. And some of the options you get look very nice, with all kinds of 3D effects and what have you, and are bordering on being completely useless. So the developer who was tasked to put together the charting package for a certain application possibly knows how to program, but certainly doesn't have a well-funded understanding of how graphs work and what is necessary to provide the best possible value in creating a certain graph. And nobody's telling him, so I wouldn't blame the developer, because normally the developer gets tasked by a product manager, and the product manager says, I want you to do this and that, and here's the specification. And if he had a good specification in front of him, he would probably have done a good job. But nobody gave him a good specification. They just told him, make a nice chart. There's also no established understanding building on top of that, how graphs should be represented for universal accessibility. And I'm intentionally not just saying accessibility, I'm saying universal accessibility. Because wouldn't it be nice if you could just read the data in the graph as a piece of software and then do stuff with it? So maybe I wanted to find out what the overall average is between all the salaries in Germany. It's not displayed in the graph, but it could be derived from data inside. If you have the number of people earning money in a certain federal state and the average amount in that state for people, then you could derive the total for the whole country and the average. So that could be interesting. And of course, it would also be interesting to provide such information to specialized reader features or to assistive technologies. So there's no understanding in general how to provide universal accessibility, not to speak of how to do that for any of the typical ecosystems or syntaxes or languages like HTML, SVG, and PDF. I think there's an accessible SVG group since 2001 or so, more or less since the times when SVG was invented. And if you look at it, the most they were able to provide so far is you can provide a description to each and every graphical object inside an SVG drawing. But there's no structured guidance exactly how to do that or how a processor of such SVG data could take advantage of that information. By just adding a little bit of text to each and every graphical object, you're not establishing a model of what's displayed by means of the SVG graphic. So that doesn't help. The same is true for PDF or HTML in general. There's no useful guidance. Because you don't have such established understanding and nobody's actually doing it in some interoperable fashion, you can't expect, for example, assistive tools to provide anything useful out of a graph that is encoded in one fashion or another. How would they do that? There's a little bit of light at the end of the tunnel. It's not from an approaching locomotive or train, so it's really light. mmer. So mmer has been around for a while, I think 1998 or something like that. So it's 17 years, I guess. So it's not the youngest kid on the block. It's also an integral part of HTML now, so most browsers should support it, some do to a certain degree. And then for the rest, the mass.js library can fill the gaps. It's becoming an official citizen of the world of PDF when we publish PDF 2.0. That's going to be pretty cool. Niels Holter will probably offer a round of drinks once we get there. He's one of the proponents that really pushed hard for it for a long time. And it's very promising. You can do very interesting things. I will show it in just a second what you can do if you follow this guidance. But still the problem is there's no wide adoption yet. There's a very small number of tools that create master structures in HTML or PDF and that can consume such structure in a useful fashion. So I will be discussing in the remainder of this presentation 3 specific use cases One is mathematical formula in PDF, then again bar charts, and then briefly music scores. And for the mathematical formula, I will do a little presentation. And so the file I'm about to open is from a professor for mathematics in Australia, Moore, whom I've had the pleasure to work with for almost 2 years now, and I've met him at least once I've met him. He's gone through the pain of creating TechPDF based on PDF 1.7, where the PDF uses the same tags that you use in mmer. He uses LaTeX, a special version of the tag formatting language, which is very common in science, especially in mathematics and physics and so on. That's what scientists use to produce their papers and publications, including the formula in those publications. And he's gone through the pain to derive the necessary tags, inject them into the PDF generated when using LaTeX. And so this is the real stuff. It's stuff he uses in his classes, so it's day-to-day content for him and his students. If you look at these formulae, I mean, how do you offer a blind or low-vision user decent access to this? Or maybe even a dyslexic or dyscalculic user that is about to learn something in this field. And you could, of course, provide alternate descriptions and talk long enough until the other person just gives up or maybe begins to understand. It's tedious. So, having had the luck of having access to these files, because they're very hard to make, we decided to take one of our tools one step further and develop something that we just call Easy Reader. And it's a demonstration tool. It's not intended to be. Let me see if I can adjust the screen a little bit. So it's a demonstration tool. And it's aiming to illustrate a few points that are important when talking about such a topic. And what this tool gives me is navigation, which we will just see in a second, text-to-speech, magnified text, presenting the current text, currently selected text, so to speak, and a couple of very specialist features to move around with this formula. So there's a shortcut to move through the text. I could move to the next heading and so on, but I could also use Control F to go to the next formula. Wherever I am, it will be highlighted. So the whole block has been formatted in mathml. So it's not, mathml was used on a formula by formula basis. The whole thing is a so-called math table and contains descriptions of each formula. The formula proto. By using certain other shortcuts, you can actually enter the formula, get inside, and move around. And while doing so, the current selection will be presented in magnified text. In some cases, especially when the expression is relatively complex, it may only provide a summary, like describing the type of expression, maybe like a table or something. So just in the previous one, it's saying it's an element of type table, because it would not make sense to just have text for the whole table. That wouldn't serve any good purpose. And it can also, you can drill down really into the formula in any way. You can also ask the tool to speak out what you are currently.
Left parenthesis, sum starting from k equals 1 to n, O with subscript k, b with subscript k.
Then go on.
Less than or equal to. Left parenthesis, sum starting from.
And let's say this is still too complex to understand right away. You could go inside and then.
Left parenthesis.
You could also ask where you are. No, how many keyboard shortcuts?
Row element with 4 elements.
Yeah,
The element with number 1 is currently selected.
So it gives you structural information about where you are, because once you're in the middle of a complex formula, you can easily get lost. So in a way you can say, well, where am I? So it gives you this structural description of the parent element. So in this case, it's really a row, it's 4 items in a row, and it tells you you're inside this row, and you're looking at the first element. That makes it clear you can expect 3 more elements to be in this row, and you can go there. So you go to the second element.
Sum started from key equals 1 to n.
And even then you can drill down and I think it's not too many shortcuts. For some reason I lost context. Let's see. Yeah. As I said, it's not a product, it's a prototype. Okay, so now it doesn't. Okay. Anyway, if it works perfectly well, you can drill down with any substructure, go up again the way you need it, have magnified text, have highlighting, have the text spoken to you, and so I consider this to be interesting, not because we made it, but because it points out what you can achieve if you choose the right approach. The right approach is to maintain structural information you have anyway, because at some point in time when somebody was writing down the formula, they were not doing it by painting it by hand, they were using a tool. Whether it's math type from design science or the equation editor Word, they wrote down the equation in this very well-structured fashion. And with today's tools, you can convert even from mmer to some other of the widely used syntaxes like LaTeX, which they use for mathematical formulas, or ASCII math, or even some very specific dialects of math, and you can more or less convert between any of these. So the challenge only is to inject the structural information you have while you put the document together in Word or LaTeX or InDesign or whatever, to maintain that information and inject it into the exported format, whether that's HTML or PDF. And that mechanism is not there yet. I expect it to happen anytime soon, so we are working on something for InDesign. I don't know by when we are going to be ready. It takes a little bit. But that would be important. Once you have the information inside inside PDF, then of course you need the tools. But to be honest, to develop the tool was not that challenging. So if any of the vendors, whether it's JAWS or Read Write Gold or whatever the tools are, they should not have too much of a hard time taking advantage of this structural information once it's there. And we're trying to prove that it can be done. We will make money by providing a special tool for the InDesign world, but we're also investing on making people understand why this makes sense in general. The most important thing to take home from this is, once you start thinking about it in this fashion, and once you assume the tools will be readily available, the author of the document will not have to do anything extra. He will have to do less than today. Today, an author asked to provide an accessible document will have to provide an alternate description. That's extra work. Once Word or InDesign were able to just inject the mathematical structure from mathematical formula into the exported PDF document, it will just happen by the software getting it right. There's no extra work required by the author. That's very important. So much about mathematical formula. Bar charts, or any such diagrams, pie charts, bar charts, whatever. I had the pleasure of working with a couple of students in Austria, in Linz, at the Johannes Kepler University, in the context of a small competition called Code for a Cause that was run over spring and summer, more or less, and Colors Software sponsored the competition. And 3 students from Linz picked up one of the challenges to figure out how to encode bar charts and how to make the encoded bar charts available to a user in an accessible fashion. And they completed the task by late August. It was presented at the AAATE conference in Budapest in mid-September. And they were the winners of this competition, part of the reason being that they did an excellent job. The other part being, and I have to be honest here, they were the only team participating in the competition. But I'm still confident they would have won even if there had been more teams, because each of the 3 invested a lot of time, much more than they would have to, because it was part of the task or project they had to do during the semester. And I think they invested at least 3 times as much time as they were expected to do. They came up with very good stuff. I learned a lot from it. And they came up with an approach they called, and they did it in the context of SVG because it's easier to do quick programming with HTML and SVG than it is with PDF. I have to admit that. And they came up with an idea of intention trees. And that's the team. They're pretty bright guys. And that was one of the prototypical charts we worked with. The tool they developed was able to do 2 things. To pick up tab delimited data, raw data so to speak, convert that into an SVG representation for presentation or drawing purposes, but also extending the data in the SVG with the intention tree, and I'll say a few words about that in a moment. So there was one part, encoding in SVG. And then also providing a tool that provided access to that information in a couple of ways. We actually had a long discussion at the beginning of the project where I asked them to just do it in HTML using CSS and so on. And they rightfully convinced me it would have been the wrong approach because it's graphical content, so you should use the graphical tag or syntax. And SVG is graphical and HTML is not graphical, not in general at least, except for the image tag and things like that. And I'm glad they nudged me towards SVG. So they invented this intention tree, and that was also another big discussion we had. I asked them to inject the extra data into each and every object that we have in the SVG drawing, and they convinced me this is not the best possible approach. It would be better to just leave the graphical representation alone and have the additional data that you will need to make the data accessible next to the data focusing on drawing, because it will make implementation easier. So if you ask an existing developer of a charting library to follow this idea, he doesn't have to reorganize his drawing procedures, he will just have to put additional data on the side in a separate tree that of course has to be linked with graphical items inside the bar chart. So that's what they did. They added a tree-like structure for the main aspects of the data in the bar chart. And then they used IDs to link certain information in the intention tree with the actual object in the graph representing that data. There you have to begin to understand how graphs work. So normally graphs consist of an invariant, the thing you're representing, like the salary or birth rate or whatever, and then you have several components. In the chart we were using here, it was election results in Austria for different federal states, and split by male or female voters. These are the components. The components can be qualitative, ordered, or quantitative, and depending on that, you will have to carefully design your chart. So for qualitative data, when there is no implied order, you should not give the impression there's a defined order. So that's one of the big mistakes that you can make when creating graphs. And of course, depending on the components that you have, like you cannot multiply sex. You cannot multiply male by female, but you can multiply or compute the average or something like that for quantitative data. And you can also not do an average on ordered data. So children, adults, seniors, there's no average. So as a result of how they encoded the data and how they built their tool to access the bar chart, they were able to do a couple of things. they could offer navigation, somehow similar to what I was showing with the mathematical formula. You could go inside the graph and walk around and walk by federal state, or walk by male versus female, or walk by year when the elections were taking place. And that can also have a couple of interesting aspects to navigation. So if you look at the election results for female voters in the federal state in 2004, wouldn't it be nice if you could look at the same thing in 2009 or whatever the other date was? So we call that visiting a cousin. So it's not a sibling or child or parent, it's like visiting the similar thing in the next branch of the tree. And that makes navigation much more useful than just walking the tree up and down. In terms of actually presenting content, they came up with the usual suspects, of course, like tooltips, selective zoom, which would be useful for people with limited vision, so they have to get closer to see something. Highlighting, maybe guide people who are dyslexic and you just need more focusing. Text-to-speech, of course. Text or magnified text, where you pull out the textual information, have a separate window, and just show the text in a very large font size. I actually missed one thing here. They also used an audio feature where the pitch of the tone reflected the intensity, so to speak. And they also did stuff where you could get subtotals. You could select two parts of the tree, and you would get the combined total for that, or you could compute an average. And again, this is just a prototype, but it was a proof how far you can get if you encode the data in a proper way, and if you have a decent understanding of what you're actually encoding, so what a graph is like and how a graph works. Coming to some conclusions about this bar chart project, it's very important that you can fully automatically create that accessible representation of the bar chart. You are very powerful in terms of styling, so in the HTML ASVG world you can use CSS and make the graph look any way you want without losing any of the accessibility. Picking the intention tree as approach makes it easy to add it to existing implementation of charting libraries. Should not be too difficult in most cases. You have very flexible access to the data encoded in the intention tree because it's linked to the actual visual rendering of the SVG content. You can do things like highlighting or navigating to the part of the tree and magnifying that part and so on. So it looks very, very cool and promising. And it's also very important, I'm not listing this here, you could use this approach to kind of any type of graph. It doesn't have to be bar charts, it could be pie charts, it could be heat maps based on a country map, and so forth. So the concept is relatively flexible. That much said, it's an early phase in this corner. It's essentially the first project I know of that did something in this field. But I'm seeing a lot of interest already, so I've just been invited to giving a talk in Japan in early February to a group of researchers in the corner of making scientific content accessible. So I'm seeing it's about to happen. Nonetheless, I don't expect any commercial solutions in the next few months, so it'll probably take a few years before you're really seeing something. And last but not least, this is a favorite of me, not only because I enjoy listening to music, but because I think it's yet another intellectual challenge that kind of gets you thinking for a while. So looking at music scores like this one, so how do you do this? So there have been projects doing something for people through the Braille display. There's specialized syntaxes for Braille, and then you can do something. But it's very specialist, so it will only be useful for people using the Braille display. It's I have been told, it's very hard to learn, so you must be really full of ambitions to become a professional musician. So you may go through that exercise, but somebody will have to encode the score for you in that special dialect of Braille. So it's not sufficiently generic to be useful anywhere else. And so I've been thinking about music scores for a long time, and I have a different view on this every other week, but this week I've been looking at it and said, well, why not encode it as a table? So isn't the information what instrument it is, and I don't even know the proper English terms, I barely know them in German, but which tone art, which...
Treble clef.
Treble clef?
Well,
okay.
Bass clef. I'm not sure what you're
yeah, how you use the notes. And then also instructions, like let's say in Largo for a couple of bars. So that could be a table header cell with a scope that goes downward. I'm not saying this is the best possible approach, but for me it's a process of thinking about it, getting feedback from users who might benefit, and feedback from people who are actually specialists in music scores. And then the interesting thing about the tabular representation is it's important that when the violin 1 plays the first bar, that the violin 2 also plays the first bar, and not the second bar. So this has to be synchronized. And a good approach to synchronizing is to do it on a bar-by-bar basis. At the same time, if you look at the bottom, I don't even know what these numbers 6 and 7 mean, but obviously they belong to the last note in the bar, the 6 at least. So if you just have the number 6 inside an empty bar, you would not know that it only applies to something towards the end of the bar. So you may have to introduce some special pieces of information, like saying, well, hang on for 3 notes and don't apply it to the first 3 notes, but only apply to the last note. So this is just to hopefully also trigger some thought processes in your brains, and maybe discuss it at some point, come back to me, or invite other people to join this. We are currently, Color Software is currently investing a little bit of money in research. I do a little bit of work on the side, but I'm busy already running 2 companies, so it's not too much time. And we hope to be able to have another Code for Cause competition between beginning of next year in July. So if you know of anybody who's willing, students, master thesis, PhD thesis, whatever, some research project doing stuff in this field, we are very interested in promoting something there. On occasion, we can provide a little bit of funding. It's not a ton of money, but it's some money, and for some students, it might be good to know they earn a couple of hundreds or maybe 1,000 or 2,000 euros. So they can invest more time than they could do otherwise in figuring out a few things. And that's another variation of the music score theme, and it's also the last slide. And if you could all please sing this together now. So my intention was to get a few thoughts going in your brains that were not there already maybe, or not in the same quality at least. I find this to be an important area of research. I hope to be able to come up, not necessarily me or my company, but us in general, with solutions you can work in reality within the next 5 years. That would be my estimate and a realistic guess by when you can see solutions that show up in some either software extensions to the big products or maybe even features in the big products, depending on how quickly certain vendors pick this up. Thank you for your attention. Thank you for bearing with us. For so long.
Thank you, Olaf. I'd love to hear some of your questions for Olaf on some of this stuff. All right over there.
Perhaps you won't like what I'm saying, because music, that's the good news. It's a standard music program which can talk with the automated VDA. So if there should be any solutions for this, then it should be that it could bring, this solution should be able to present data better than the standard music program. I don't think that will be the case. The solution about presenting data on created input for LaTeX would, on the other hand, be very interesting, because the program in Denmark, we use LaTeX for mathematics from the middle of the school. So the children learns to write their mathematical formulas in LaTeX. And we like very much a program that can present it so any sighted person can understand this formula. So here I think that would be a good help for us because the programs that graphically present graphs from the text version of LaTeX is not, you can't control what you are presenting. So if you, with this PDF solution, you will be able to control what you are presenting. That needs to be very a big thing for a blind person working with it. But we are working with LaTeX in Denmark, and the music situation is covered by a standard music program called CBS.
Okay. I think this is rather a comment than a question.
Questions?